In lesson 4, we're going to be talking about biconditional statements. The biconditional statement is the fifth and final statement that we're going to learn in chapter 2. And we know from before that the prefix bi means two. So they take two statements and they kind of put it into one. The two statements that they use are the conditional and its converse. When you have a biconditional statement, it is written in the form P if and only if Q. So those are the key words to a biconditional. It means if P then Q and if Q then P. Symbolically, you'll see it like this. P if and only if Q. Meaning if P then Q and Q then P. So the double arrow is the symbol for the words if and only if. Sometimes it's also abbreviated, IFF, if and only if. In example A, you can see that we are actually given a biconditional statement, and they kind of ask us to dissect it here. They ask us to come up with a conditional and then to come up with the converse. So number 1, it says that the Colonels will win if and only if they score more than the opponent. If I'm looking for the conditional, I'm looking for the if-then statement. And we could say something like, if the Colonels win, then they will score more than the opponent. And we know from before that the converse would simply be the flip-flop of that statement. I'm going to flip it around, where I may say, if they score more than the opponent, then the Colonels win. And question 2 would be more of the same. Again, in the biconditional statement, they've abbreviated. So this is going to read, an angle is obtuse if and only if its measure is greater than 90 and less than 180. Where if we're going to dissect it, my conditional statement, I may say, if an angle is obtuse, then its measure is greater than 90 and less than 180. And my converse, flipping that around, if an angle measures greater than 90 and less than 180, then it is obtuse. You may also see questions where you're given a conditional, and then they simply ask you to write the converse, and then write the biconditional. So in number 1, where it says if 5x minus 8 equals 37, then x equals 9, we know the converse of that, flipping that around, if x equals 9, then 5x minus 8 must equal 37. My biconditional, I'm looking to add those key words, if and only if. And in fact here, typically they go back to starting with a conditional statement. My biconditional may look something like this. 5x minus 8 equals 37 if and only if. Maybe I'm going to use symbols. X equals 9. That is one way to write it. As you flip your paper over, example B on the back, we're doing more of the same. Here, my biconditional, or my conditional states that if it is July 4th, then it is Independence Day. We know the converse would simply be switched around. If it is Independence Day, then It is July 4th. Biconditional statement, well, there are a couple possible, but mine may say something like, it is July 4th if and only if it is Independence Day. Now the question in it is that true? It is July 4th if and only if it is Independence Day? Yeah, that's true. What if it said it is Independence Day if and only if it is July 4th? That is also true. A biconditional, they may ask you to determine if it's true or false. And for the biconditional to be true, both the conditional and the converse must be true. So what I tell students is it has to work both ways. It has to be true both ways. And I recommend reading the conditional and the converse out loud. If either one of those is false, then the biconditional itself is going to be false because it doesn't work both ways. So looking at a few of those examples, in example C, for determining if the biconditional is true, number 1, an angle is a right angle if and only if its measure is 90 degrees. I'm going to look and I'm going to test it both ways. So I'm going to say if an angle is a right angle, then its measure is 90 degrees. Yeah, I agree with that. Now let's check the converse. If its measure is 90 degrees, then it is a right angle. I also say true. And so because that works both ways, that biconditional is going to be a true statement. Number 2, y equals negative 5 if and only if y squared is 25. So I'm going to check it both ways. If y equals negative 5, then y squared is 25. Agreed. If y squared is 25, then y is negative 5. Now in this case, that is true, but there are other cases that would work as well. So it's not for sure that y is negative 5 because y could also be 5 and that still work. So y equaling 5 is my counter example, which means this is going to be a false biconditional. It does not hold true 100% of the time. Number 3, an animal is a blue jay if and only if it is a bird. Well, if you check it both ways, if blue jay, then bird. True. If bird, then blue jay. That is going to be false. It doesn't guarantee that if I'm a bird, I'm a blue jay. I could be a robin or a sparrow or something like that. So I'm going to say, I'm just going to say, could be a robin. In the box below, it says that in geometry, biconditional statements are used to write definitions. A definition is a statement that describes a mathematical object and can be written as a true biconditional. Most definitions in the glossary are not written as biconditional statements, but they can be. The if and only if is implied. So in example D, we have the given definition. A pentagon is a 5-sided polygon. We're thinking about how that would sound if we wrote it as a biconditional, meaning we need those keywords if and only if. Sometimes you have to add in additional words in order to make it sound better or to make it make sense or just to make it sound the best, I guess. In this case, I may consider saying a pentagon, no, a polygon is a pentagon if and only if it is a five-sided polygon. Or I can maybe say a figure is a polygon. Either way would be fine. And there are other ways that could be written, just using slightly different words, but again, your keywords, if and only if, need to be included. Okay, there's also more online example videos that you can access via our online textbook. And if you have questions, please be sure to come in and see me.